Hello students, this is Miss Dalton, and this is the last section on the word problems for rational functions. So these problems involve motion, and so something that I want you to remember is remember the formula distance equals rate times time. So when you read these problems, you're going to create what I call a DRT chart. You're going to fill out the distance, fill out the rate if you have it, fill out the time if you have it, and then solve for what you're trying to find. So you're going to solve using the D equals RT equation, and then make sure you set up your equation. If you're looking for total time, then you want to do the T plus the T. If you're wanting them to have equal time, then you do T equals T, R equals R, D equals D, etc. And then solve. So let's look at this first problem. So we have that Terry can run 15 miles in the same time that it takes Mark to run 21 miles. If Mark runs 2 miles per hour faster than Terry, how fast does each of them run? So let's first start by making a chart. So we're going to have, let me get to my pen. We're going to have distance, we're going to have rate, and we're going to have time. And this is going to be for Terry and Mark. So it says that Terry runs 15 miles, that would be the distance, in the same time that it takes Mark to run 21 miles. And if Mark runs 2 miles per hour faster than Terry, so since Mark's speed is dependent on Terry's speed, Terry is going to be our X, and then that means that that Mark runs X plus 2 times faster. And then how fast does each of them run? Okay, so the time is equal. And so we're going to manipulate the D equals RT formula to get time by itself. So you would have to divide both sides by R, and that would give us our time. Since we know that their times are equal, then what we're going to do is we're going to take the distance divided by the rate for each of them and set it equal to one another. So if I take Terry's distance of 15 and divide it by his rate of X, I'm going to set it equal to Mark's distance, 21, divided by his rate, X plus 2. And then this is just solving using cross multiply. So let's go ahead and do that. We would multiply this one first. So that would be 15x plus 30. Make sure you distribute. And then you set it equal to the other multiple, 21x. And now we're just solving. So we would subtract 15x. That would give you 30 equals 6x. And then divide both sides by 6. So X is 5 miles per hour. Now remember, X is what Terry runs. And then to get Mark's, we would just have to do 5 plus 2. And so Mark runs 7 miles per hour. And that would be your answer. So Terry runs 5 miles per hour, and Mark runs 7 miles per hour. All right, let's look at this next example. It says Harriet drove for 90 miles in slow traffic on a 2-lane road before getting on the tollway. When she got on the tollway, she increased her speed by 20 miles per hour, and she drove for 130 miles. If she drove for a total of 4 hours, how fast was she driving on the tollway? So let's make our chart. So we have Harriet, and she was driving on a 2-lane highway or 2-lane road, and then she was also driving on the tollway. And let's do our distance, our rate, and our time. So on the 2-lane road, she drove a distance of 90 miles. On the tollway, she drove a distance of 130 miles. On the 2-lane road, let's just call that X because we don't know what her speed was, but when she got on the tollway, she increased it by 20. So X plus 20. And then the time is going to be a total of 4 hours. So we're still, because we've got our time, right? We need to know what the formula for time. So we would divide both sides by the radius. So the time equals distance divided by r again. So we're going to take the distance divided by the rate of the 2-lane road, which is just 90 over x. We're going to add it because, again, we have a total time of 4 hours. So we're going to add that. So 130 divided by x plus 20. And together it should equal 4 hours. Okay, so this is an LCD formula. So our LCD is x and x plus 20. So 90 would have to get multiplied by x plus 20. 130 would get multiplied by x. And 4 would get multiplied by x and x plus 20. Again, if you don't remember how to do that, look at the last unit, 10.4. So now we would just solve this. So this would be 90x plus 1800 plus 130x. This would give you 4x, and then when I distribute that, that's going to be 4x squared. And then 4x times 20 is 80x. So since I have a squared, I got to get everything on one side. So I'm going to keep my 4x squared positive. I'm going to combine my x's. So you get negative 140x. And then move the 1800 over. So that would be a minus 1800. And that's going to equal 0. I can divide everything by 4, thankfully. So I have x squared minus 35x minus 450. And then I'm going to factor that. So factors of negative 450 that add up to negative 35 are negative 45 and positive 10. If I set those equal to 0, I get x equals 45 and I get x equals negative 10. Well, since you can't have a negative speed, that doesn't make sense, then this is what x is. And it says, how fast was she driving on the tollway? Well, the tollway was x plus 20. So you would need to do 45 plus 20. So she was driving 65 miles per hour. All right, let's look at this next example. It says a kayaker traveled 5 miles upstream and then 8 miles downstream with an average current speed of 3 miles per hour. And we're talking about the current of the water. If the trip took 3.5 hours, what was the kayaker's average paddling speed? So let's look at our distance, our rate, and our time. So we're looking at the upstream, and we're looking at the downstream. So let's fill in what we know. So it says a kayaker traveled 5 miles upstream, so that's the distance, 8 miles downstream. Okay, it says it has an average current speed of 3 miles per hour. Well, if you've never kayaked or, been in a boat, when you are going upstream, that current, if it has a speed of 3 miles per hour, that's working against you. So you're going to take whatever your speed is and you're going to subtract 3 because it's going to push against you. If you're going downstream, that's a lot easier to paddle because the current is working with you. And so whatever your speed is, you're going to add 3 to it. And it says the trip took a total of 3.5 hours. So together, that took 3.5 hours. Again, we're using the time equals distance divided by rate formula. So we're taking our distance of each and dividing it by the rate. We're going to add to it the distance divided by the rate of the downstream. And together that should equal 3.5 hours. And so now we're just going to solve this. So again, we're going to use the LCD. And I want to show you how to do this on the calculator. Okay, I want to show you how to do this on the calculator. So what we can do is we can take the left side of the equation and we're going to put it into y1. And then we're going to take this right side of the equation and we're going to put it into y2. So this is going to look like this. So we're going to go to y1. We're going to do alpha y equals. We're going to type in 5 over x minus 3. And then we're going to do plus alpha y equals 8 over x plus 3. Then we're going to go to y2 and we're just going to type in 3.5. Now go to your graph. What you're going to see is you're going to see that we have the blue graph and the red graph are intersecting. Now they're intersecting at 2 different points, right? We've got a point here. We've also got a point over here. And on mine, I can kind of scroll to it and see where it is. But here's how you would do it on yours. You're going to go to second, trace, because we want to go to the calculate screen. And we're trying to calculate the point of intersection, so number 5. Now, it's going to ask you to get on the left side of your intersection point. So anywhere on that left side, hit enter. And then go to the right side of your intersection point. So I'm just trying to find this first one on the left. Hit enter. And then it's going to tell you, we'll see the intersection is right here at negative 1.28. Well, that's a negative value for a speed. Well, that's not going to work. We can't have a negative speed. So we need to find the other point of intersection. So go to second, trace, calculate your intersection again, but this time we're going to get on the negative side of the other point of intersection. So we're just going to get as close to it as we can. We're going to hit enter. And then you want to get on the right side of that point of intersection, right there, and hit enter. Now, do you see where we have this point of intersection right here? The x value is 5. So that means that my x value is 5 miles per hour. Well, let's see what it's asking us to find again. It says, what was the kayaker's average paddling speed? Well, that's our average paddling speed right here, 5 miles per hour. So this is something that you can do when you are trying to find a solution. You can take the left side, put it into y1, take the right side, put it into y2, and then find the point of intersection. Okay, I hope that was helpful. Let me know if you have any questions.